start things off. So what we're going to talk about is numbers today. So different types of numbers, different categories of numbers. We're going to start off with talking about something called irrational numbers and rational numbers. To learn about those, we're just going to calculate a few fractions here and turn them into decimals and try to notice a couple things about them. So we'll start off with this fraction, which is 28 divided by 11. This guy right here is the one I'm doing. So in your calculator, to put a fraction in your calculator, it just means divide. Right? That's what a fraction is. So in your calculator, you go 28 divided by 11. And you're going to convert that to a decimal. You're going to get 2.5454. And then it keeps going, right? When it keeps going, we write a line over it like that. So when you see a line on top of something, that means the 5 and the 4 are going to keep repeating in that order. 5, 4, 5, 4, 5, 4, 5, 4. If the line was only on top of the 4, that would mean the 4 is repeating forever, right? 4, 4, 4, 4, 4, 4, 4, and so on and so forth. Awesome. We're going to answer a couple questions about this. I don't like the yellow. It's kind of weird. The decimal representing 28 over 11 has a repeating pattern. And it goes 5, 4, 5, 4, 5, 4. And does not terminate. That means that it would go forever. It would repeat forever and ever and ever. And every decimal is going to fall into a couple categories. It's either going to be repeating or non-repeating. And it's either going to stop or not stop. And it's going to be one or the other on all those options. So we're just going to look at a few numbers that have different scenarios. This one is repeating. 5, 4, 5, 4, never stops. If we look at the second one, 28 divided by 8, we put that into our calculator, convert it into a decimal, and we get 3.5. If we had to talk about that decimal, we would describe it as non-repeating, right? There's no repetitions there, so non-repeating. And we would describe it as terminating. It terminates because the decimal stops, right? Like it went 3.5, done. It didn't go 3.5555555. Okay? We describe that as terminating. That's the words you're going to have to know. Awesome. The last one that we're going to put in our calculators is the square root of 2. To put the square root of 2 in your calculator, if you have one of these fancy dancy calculators, you'll notice a little, mine's blue, square root symbol on the left-hand side. My actual button is x squared, and then in the blue writing above it, it's the little square root sign. So that is your square root button. To use any of the blue symbols, you go second, which is up here, second, and then you click that button, and it'll bring up the square root sign for you. And then you can put in 2 and hit enter, and they'll do the square root of 2. If you don't have one of these calculators, your square root button's somewhere on your calculator. You might have to put the number 2 in first and then hit the square root button, or you might have to go square root and then put the 2 in. It depends on your calculator, and there's a gajillion different ones, so you just got to figure it out on your own or ask for help. Okay? When you put the square root of 2 in your calculator, you get 1.4142562, and that actually keeps going. Right? Like your calculator doesn't have enough room to keep telling you the next numbers. But once you have that many decimal places, you can assume it's going to go forever. If we were to describe that number, we would describe it as non-repeating. You look, there's no pattern there. It goes 4142135562. There's no pattern there. It kind of looks like it might start off as a pattern, but it's definitely not. So we say that is non-repeating, and it goes forever, so it does not terminate. Those ideas about terminating and repeating and all that jazz is what gives us 2 different types of numbers. And those are the 2 types of numbers we're going to learn about first. We're going to learn about rational numbers and irrational numbers. Okay. They've written out those definitions for for you right here about repeating, non-repeating, terminating, non-terminating. So if you ever are like, what the heck does he mean by terminating? You can look back at this page and be like, oh, terminating means decimals with a finite number of digits. It means it stops. Awesome. We're going to convert some of these. Oh, sorry, I'm hitting the wrong button. We're going to convert these to decimals, okay? And we're going to classify them as repeating or terminating for each of them. So let's start off with 1 over 8. 1 over 8, I put in my calculator, I get 0.125. Would that be a repeating decimal? Nope, that thing does not repeat, so it's non-repeating. I'm just putting non-rep. Does that decimal terminate? Yeah, right, it stops, so we would say it terminates. Kind of get a hand of it. Also, I'll do one more, then you can try the next ones on your own. You got 2 over 11. Actually, we've already done fraction. Let's do square root 8. So we'll do e together. If you do the square root of 8 in your calculator, you get 2.828427125, right? It just keeps going forever. Is that a repeating number? No, we say that's non-repeating. And it goes forever, so we say it's non-terminating. Doesn't repeat and it doesn't terminate, goes forever. Awesome. Try the other ones. So try B, C, D, and F, and try to list them all as non-repeating or non-terminating, or repeating or terminating. Okay, so you're told. When you put all these in your calculator, you would have got different answers. When you put 2 divided by 11 in your calculator, what decimal did you get? You had 0.12. Was it? 1.8. And then it went 1.8, 1.8, 1.8, 1.8, 1.8, right? So if you had that, we would say it's repeating. Because it goes 1.8, 1.8, 1.8, 1.8, 1.8. And we would say it's non-terminating. Because it goes forever. Awesome. The next one, 9 divided by 7. 9 divided by 7 looks like something that doesn't repeat. If you look at it, it looks almost random. It's like 285,714. Right? It just keeps going. But if you notice, it repeats itself. 285,714, and then 285,714, and then it would go again. 285,714. So that actually is a repeating decimal. It just does not look like a repeating decimal. Okay? It looks like it goes forever and ever. When I first looked at it, I got confused because I was like, oh, that thing's not repeating. However, I know a trick. And a trick is that all fractions will either terminate or repeat. Okay, so I knew because this was a fraction, it must have repeated. Because it definitely wasn't terminating, right? So looking at that, I had to look really hard to find the pattern. But it was there. So this repeats and is non-terminating. And you can definitely use that trick too, right? And be like, well, I know fractions will always repeat or terminate, one or the other. D. They've actually written it for you already. They've changed it into a decimal. They put a little line above the 4. The little line means that the 4 is repeating forever, right? That's what that little line above the 4 means. That means this thing repeats and is non-terminating. If you actually wrote it out, it goes forever. Awesome. The last one, the square root of 0.16. If you put that in your calculator, you get 0.4. That would be a non-repeating. And it would be a terminating. It stops. The word terminate means to stop. Awesome. What we've actually been doing by classifying these things as non-repeating or terminating is we've been deciding whether numbers are rational or irrational. Okay, those are two different types of numbers. You have rational numbers, you have irrational numbers. And depending on if they repeat or terminate or any of that stuff, depends on which group they fall into. That's what this first lesson is going to be about. Rational and irrational numbers. Right? They've written the definition for you. Rational numbers are rational numbers that repeat forever or terminate. Okay? One or the other. Doesn't have to be both. In the definition, they put that they repeat or terminate their rational numbers. If they don't do one or the other, if they don't repeat and they don't terminate, we call that irrational. Okay, so non-repeating, non-terminating, we call irrational. So if we look up at the example we just did, what we've really been doing is we've been calling these things rational or irrational. Okay, look at the first one. It's non-repeating, but it terminates. That means it would be a rational number. The middle one, it repeated forever. Repeating means rational. This one, repeats forever. That means it's rational. This one, repeats forever, rational. This one, non-repeating and non-terminating would mean irrational, right? Because it didn't have either thing. It went forever and it didn't repeat. Last one, non-repeating, however, it terminated, right? It stopped. That means it's rational. We've actually been classifying these things all the time. We just haven't really known it yet. So we got 6 examples. We're going to write these things out as rational or irrational. Okay. We look at the first number. It's 1.493. Does that repeat forever? No, definitely not, right? Does it terminate? Meaning, does it stop? Yes, it does. So as long as you say yes to one of those questions, it's a rational number. Right? Just one or the other has to happen. The middle one, we have the square root of 5. I have no idea if the square root of 5 repeats. I have no idea if the square root of 5 goes forever. So I don't know if it's rational or irrational. So what I need to do is convert it into a decimal, right? And then I can figure it out. When I calculate the square root of 5, you get 2.36067977499979. It does not look like it repeats. Right? I don't see any pattern in there. Does it look like it would go forever? Yeah, right? There's a lot of decimals there. So odds are it keeps going. After about 8 decimals, you can pretty much assume it's going to go forever. So this thing, non-repeating, non-terminating, means it's irrational. All right, you look at C. You have 2.34734734737. That is definitely a pattern. Right? They can put a little line over the 347. That means it's repeating. Repeating means rational. I'll give you a second to try the 3 below, okay, and then I'll fill in the answer for you. But just give it a try. There we go. We're going to look at the first one. So D, it says negative square root of 81. If you put that in your calculator, you would end up getting negative 9. These ones are kind of tricky. If we talk about it right now, it's going to make sense. But later on, when you get a question like, hey, is this rational or irrational, it kind of throws people off. Because it's not a decimal. Right? There is no decimal there. It's just 9. And sometimes that makes people panic, okay? Because technically it's non-repeating, correct? And then it comes down to terminating. And people are like, well, there's no decimal, so I don't know if it terminates or not. If there's no decimal, that means it terminated just before the decimal even started, right? We could call this 9.0 if we wanted. We just don't do that. So this thing still classifies as terminating, even though there is no decimal, which means it's rational. Awesome. If you put the middle one in your calculator, the square root of 4.41, 4.41, we're going to square root that. We get 2.1. Well, that's lucky because I was going to say irrational, so I calculated it. When you get a decimal 2.1, that definitely terminates. Terminating means rational. And the very last one, we have 8.11221112221111. My guess is it's then going to go 2222, right? And then 1111. Okay, that is a pattern, right? However, it is not repeating pattern. So don't get those two ideas mixed up. This is a really rare situation. It's never going to happen, right? But it's technically not repeating. It's just a pattern. This does not count as being a rational number because it's not repeating and it's not terminating. This would be an irrational. Which I just forgot how to spell irrational. Right? Because what we're looking for is repeating and terminating, not necessarily just a pattern. Awesome. There's number line stuff here. We're going to skip the number line stuff. We're just going to go down to converting repeating decimals to a fraction. So the cool thing, remember what I said to you before, was that I know all fractions will either terminate or repeat forever, right? That means fractions automatically are rational numbers. And sometimes we, as math students, forget that like the rule is repeating or terminating, and we just remember fractions mean that we can get a rational number. Right? That's all we remember. Fraction, rational, fraction, rational. So what people learn is that if you can turn something into a fraction, you can tell if it's rational or not. Your fancy dancy calculators can actually turn numbers into fractions for you. It'll either turn into a fraction or it'll say it can't turn it into a fraction. It'll give you the decimal back. So if you don't have one of these calculators, try to sit right next to someone so you can move your desk, slide over. I just handed a whole bunch out, so there should be enough out there that people can partner up. Even if it's someone you don't know, all you're looking at is buttons on the screen. So I just want you to get used to it so like you can slide over here and partner up. But I want you to see this because we're going to use this through the rest of your math life. Okay? So you probably want to know what it looks like. If you have one of those fancy calculators, maybe just look around you and share if you need. Awesome. Changing things into a fraction. What you're going to do is you're going to put the decimal into your calculator. So the first question they gave us was 0.36, and they put a line above it. So that means 36, 36, 36, forever and ever, right? Type that in your calculator. So go 0.3636363636 and put a lot of them, right? Fill up like the whole top line on your calculator. So your calculator knows, oh, okay, it's 36 forever. If you only went 3636 and then stopped, they might think that you aren't going forever. So that's why I say fill the whole top line like this on your calculator. Good. All right, the fancy button that you need. This calculator is dead, or I would share it with you guys. Okay, so to turn things into a fraction, you want to hit the math button. It's on the left-hand side. When you hit the math button, it's going to bring you to a whole list of things, right? It's going to say like 1, 2, 3, 4, 5, a whole list of things. The very first option is a little arrow with the word frac. The little arrow means convert to, frac means fraction. So the first option means convert to a fraction. You're going to hit option 1. You can either hit 1 or hit enter on 1. And it'll bring you back to your home screen, and it'll now say this. This means turn that decimal into a fraction. And if you hit enter on your calculator, it will actually show you what the fraction is. So 0.363636 equals 4 over 11. And as we get going in this course, you're going to notice we don't like to use decimal answers. We use fraction answers a lot. So being able to convert using your calculator into a fraction is a very useful tool. That's why these calculators are going to be important. No other calculator will do that. Okay? You can try again with this one. So B. If you look at B, it's 3.95. The line is over the 5 only, so that means 3.95, 5, 5, 5, going forever. Fill the whole top line in your calculator, so 3.95555555555. And then we call it, if you talk to many of the teachers, they'll say math bracket, right? Because those are the buttons you're going to hit. So you're going to hit math, and then the frac option, number 1. Math bracket. You go math, frac, enter. It will tell you that this turns into, I don't know how a calculator works. What's the fraction? A little louder, 178 over 45? Yeah. It's a crazy fraction. But it works. If your calculator, so say you put in a decimal, right? Gives you the decimal number back. So it didn't work, right? So you put in this big decimal, you do math frac, and it just gives you the decimal back. That means it's an irrational number. You couldn't write it as a fraction. Okay? So for instance, if we look back up here and we took like this guy, the square root of 5, right? Turned it into that crazy decimal. If we tried to turn that decimal into a fraction, it wouldn't work. Because irrational numbers cannot be written as fractions. That's how I know that trick. Fractions mean rational, non-fractions mean irrational. Awesome. We are going to talk about math frac like over and over and over again. So if you didn't have a calculator today, try to get one as soon as possible. This weekend would be a good time to get one. And then ask, right? And stay caught up with the calculator work, because we're going to build with these calculators all year on how to do things. There is like steps on how to convert things algebraically. We don't do that. So there is like an algebraic process, which is, it's kind of crazy. It's very tedious, and you'll never be expected to do it. All right, it's much easier to just go math frac in your calculator. Awesome. We're going to stop there for about 15 minutes so you guys can work on these assignments. You're just classifying things as rational or irrational. All right, and then we're going to talk about the next lesson.